Okay, so in this problem, we're going to take a look at solution stoichiometry. And what that means is we are going to use our knowledge of this formula. Sorry, molarity is equal to number of moles over volume. We're going to use our knowledge of this and relate it to actual reactions. Talking about reactions, there's a little question mark out here. That's a mistake. It should have been a reaction arrow. All right, so the reaction we're looking at out here is a balanced reaction. It is Na2CO3 plus 2HNO3 gives us 2NaNO3 plus CO2 plus H2O. Okay, you can double check to see if it's balanced. It's always a good practice to double check. All right, the question that's asked of us is what volume in ml of a 0.150 molar HNO3 solution will completely react with 35.7 ml of 0.108 molar Na2CO3 solution, according to this equation. All right, so to do this problem, it's important to understand what the relationship is, as per the equation, between Na2CO3 and HNO3. Okay, so if you look at the equation, you can see that 1 Na2CO3 reacts with, I'll just write it down, reacts with 2HNO3. You can use this relationship to create a conversion factor. Okay, so I'm just going to make that 2HNO3 over 1 Na2CO3. You can do it the other way too, but in this problem, the question is asking us for what volume of 0.150 molar HNO3, which means we have to find out HNO3, so it makes sense to put HNO3 on top. All right, so once we have that conversion factor, the next thing we got to find out is when you're looking at a reaction, it's important to understand how many moles are reacting. Okay, so which means if you can take this information given to you, 35.7 milliliters, and the molarity, and using this formula, you can calculate the moles. So let's go ahead and do that. So if I rearrange this formula and isolate the N, I get N is equal to M times V. Molarity is 0.108 molar, and let's write that in moles per liter. And the volume is actually 35.7 ml, which we can change to liters, which would be 0.0357 liters. It's always important to change milliliters to liters when you're using this formula, simply because by the definition of the formula, volume is always in liters. Okay. All right, so if we simplify that, we get 0.00385 moles. All right, so now we know the moles. Now we can use this relationship to figure out how many moles of HNO3 react with these many moles of Na2CO3. Okay, so we'll just do 0.003855 moles of Na2CO3 times that relationship, which is 2HNO3 over 1 Na2CO3. And we can solve that to give us 0.007711 moles HNO3. All right, once we have that, the next part is to take this moles and then take the molarity out here, and then using this formula to back into the volume. So if I rearrange this formula to solve for volume, I get volume is equal to number of moles over the molarity. So let's go ahead and do that. So the volume is equal to number of moles, so that's 0.007711 moles over the molarity, which is 0.150 molar. Let's rewrite that as moles over liters. And if I solve that, I get 0.051408 liters. Again, if I change that to milliliters, since the question is asking us what volume in milliliters, I get 51.4, and I'm correcting for significant figures out here. So that's 51.4 ml. And there you have it. That's how much HNO3 will react. All right. So an extension of the same problem is in the next part, which says for the reaction above, what mass in grams of carbon dioxide forms. Okay, same relationship. So take a look at the reaction out here. You can see that 1 Na2CO3 makes 1 carbon dioxide, which means the relationship that we can write is 1 CO2 forms from 1 Na2CO3. So if we use that, we know that the moles of Na2CO3 that were reacted is that number. So let's use that 0.003855 moles Na2CO3 times 1 CO2 over 1 Na2CO3. That gives me the same amount, 0.003855 moles CO2. Now, I'm going to convert these moles to grams because the question is asking us for grams. To convert moles to grams, we're just going to take the moles and we have to multiply this with the molar mass of carbon dioxide. Molar mass of carbon dioxide happens to be 44.01 grams per mole. On multiplying it out, we get 0.16965 grams. Now let's correct for significant figures. So we get 0.170 grams carbon dioxide.